is central limit theorem? The central limit theorem says that the sampling distribution of the mean will always be normally distributed as long as the sample size central limit theorem is large enough. And I will give you an example. Example, according to the National Center of Biotechnology Information, the average of American with Alzheimer's disease is first diagnosed is 74.7 years. Assume that the population standard deviation is 8.6 years. If a random sample of 35 patients who have been diagnosed with Alzheimer's disease is selected, what is the probability that the mean age of the sample size and that the sample is greater than 71 years? In order to answer this question, we must first understand the central limit theorem. The central limit theorem states that as the sample size increases without limit, the shape of the distribution of the sample means will approach a normal distribution. It is important to remember two things when using the central limit theorem. If population is normally distributed, then the sampling distribution will always be normally distributed regardless of sample size. If the population is not normally distributed, then the sampling distribution is approximately normally distribution is the sample size is at least 30. The sample size for this problem is 35, so we will use the normal distribution to find the probability. The question is asking us to find the probability that the sample mean is greater than 71 for the sample of 35 patients. So, minus mean we will use a z-score to find the probability. It is very important that we use the standard deviation for the sample distribution, also called error of the means. When calculating a z-score associated with a mean of a sample, the standard deviation for sampling distribution is found by dividing the standard deviation for population by the square root of the sample size. So we will substitute the sample mean, population mean, standard deviation, and sample size into the formula. This will find the result in a z-score of negative 2.55. So finding the probability that the sample mean is greater than 71 is the same in this case as finding the probability that the z-score would be greater than negative 2.55. It is always helpful to draw an appropriately shaded curves when finding probabilities associated with a normal distribution. Our z-score of negative 2.55 will be between the z equals negative 3 and z equals negative 2. We are going to find the probability about the z-score for the sample mean would exceed negative 2.55. So we will shade the region under the normal curve to the right of z negative 2 equals negative 2.55 using a tool such as a normal probability table or a graphing calculator, we would find that the proportion of distribution occupied by that shaded area is 0.9946. So the probability that the z-score would be greater than negative 2.55 is 0.9946. Another way to say it is by saying 99.46% of an sample size 35 among people diagnosed with Alzheimer's disease would have an average age of diagnosis that is greater than 71%. 71 years. Thank you.